All right, in example 3, it says to determine if the following functions are one-to-one. See, I'm trying to read the directions more because that's what happens a lot in a math class. Students forget to read the directions. But state the inverse is the inverse a function. So we're thinking back about, is it a function? Is it one-to-one? Well, actually, they said determine if the following function. So they told us that these are functions. Is this one-to-one, and why? Yes, it's one-to-one. Yes, it's 1-to-1. Okay, what would the inverse be then? All I have to do to find the inverse is just swap the x and y's. 36, yeah? Is the inverse a function? Yes, the inverse is a function. So we'll call this the inverse here. The inverse is a function. And by the way, if something is one-to-one, its inverse has to be a what? A function. Is this function one-to-one? So it's not 1-to-1 because y equals 20 is repeating. So if we find the inverse, what's the inverse? Yes, and 26 and 10 negative 8, good. Is the inverse a function? It is not a function. And that's, again, because here now my x equals 20 is repeating when I find the inverse. Okay, determine if the following functions are one-to-one. So everything here is a function. That's because I could draw vertical lines through each one, and I'm not going to cross any point more than once with a vertical line. Is this function one-to-one? Yes, it's 1-to-1. Now, you could come up with the equation of this line. What is the equation? Anyone know, just looking at it? You know anything about the y-intercept? Yeah. So the slope has to be negative because the line is going down. Our y-intercept is 2, so it's plus 2. And then our slope is negative. I went down 2 over 4. So slope, m, equals negative 2 over 4. What does that simplify down to? Yeah, negative 1/2 x. So a couple of different ways you could find the inverse. You could go through that whole process. I don't have a lot of space on the page here, so I could do that. I could take out some more paper and do that whole process and find it algebraically. But on the graph, it's just going to swap all of our x and y. So if you find a few points, what's this ordered pair of that point right here? 0, 2, right? Now go ahead and swap the x and y, and what's the swapped point going to be? 2, 0. Okay, let's find another point on the graph. What's this point, this ordered pair right here? 4, 0, right? Tell me what the swapped point is going to be. 0, 4. So if I swap two of the points, and then I go ahead and draw my line, that's the inverse function, right? Can anyone tell me what the equation of that line is going to be? I went down 4 over 2, yeah? And my y-intercept is 4. Y equals negative 2x plus 4, is that right? And if you were to draw the line y equals x, Do you see that it's a reflection over that line? So a couple of different ways to do that. So draw the inverse on the graph. Is the inverse a function? Here we drew the inverse. Yes, it's a function. The inverse is. Okay. Now let's look at this one. Does this one pass the horizontal line test? If I draw a horizontal line, am I going to cross more than one point with a horizontal line? Yeah, here if I draw, what's the equation of this line right here? Y equals 8. I'm actually hitting that graph multiple times. So this one is not 1-to-1. I forgot if we answered that question. Oh yeah, we said that back here. Yes, this one was 1-to-1. Okay, so if I still want to draw the inverse, even though is the inverse going to be a function? No. So how would I draw the inverse? Well, I could take a few points, ordered pairs. So what's the ordered pair of this point? -8, 2. Okay, maybe we could do a table of values, x, y. -8, 2. And then here's another point where it changes directions. What's the ordered pair of that point? -2, 8, right? And then what's the ordered pair of this point? -6, 8. Now if I want the inverse of that, so I'll do the inverse over here, inverse. The inverse just swaps the x and y values. So what are my new points? 2, -8. What else? Good. 8, -2, and 8, 6. Can you see that now the x values, x equals 8, is repeating? So if I want to plot this, I have 2, -8. I go over 2, down to -8. That's the inverse point. 8, -2. I go over to 8, down -2. And then 8, 6. I go over to 8, up to 6. Right here, this would be the inverse. So is the inverse a function? No. The inverse, it's not 1-to-1, so the inverse is not a function. I'll switch colors for the next one. Okay, let's look at this one. Does this one pass the horizontal line test? No, because if I were to draw a horizontal line here at y equals -4, I would hit the graph twice. Maybe what I'll do, save space over here, I'll go x, y, and then we'll do our inverse over there. So give me some points. I think these critical points, these would be the best ones to use. So what's the first ordered pair that I plotted here? Is that right? And then this one is, good, 4, 2. And this one is 8, -6. Good, 8, -6. And there's, again, where we're seeing that repeat. Then if I want to find the inverse is going to be the opposite, or we're going to swap the x and y's for the inverse. And go ahead and swap them. What do you get? Go ahead. Yes? Good. Now let's plot those. -6, 0 is over here. 2, 4. Go over to 2, up to 4 is here. -6, 8. Go -6, up 8 is here. And right here, this is our inverse. It's kind of hard to visualize unless you actually write the ordered pairs and then swap them. I think it's hard to do it without doing that, but you will see this, just like I was saying before, here's the line y equals x, and you will see that mirror image over that line. Is the inverse a function? It's not 1 to 1, so the inverse is not a function.